Hello, my little mathematicians. Today, we are going to go through one of our final study guide number 4. As always, please feel free to pause the video, try it yourself, and then unpause it and come back with us. Okay, so if we're going through number 1, let's see if you got it right. It says, find all the whole numbers between 2 squared and 3 squared. Well, 2 squared is 2 times 2, which is 4. And 3 squared is 3 times 3, which is 9. Because squared means that number times itself that many times. So 2 times for the 3 and 2 times for the 2. So the numbers between there are 5, 6, 7, 8, and it wants just the whole numbers between those. So there you go. All right. For our next one, it says simplify 5 cubed. So this one was 3 times itself 3 times to give us 9. This one is 5 times itself 3 times because that's the exponent. It's 3. So 5 times itself 3 times is, well, 5 times 5 is 25. Bring down the other 5. And 25 times 5, that's 10, 11, 12. So 125 is what 5 cubed or 5 to the 3rd power is. Okay, our next one asked us to solve this equation. And whenever you solve an equation, you want to get the variable by itself. So what's preventing that variable from being by itself? This minus 2. So do the inverse operations. What's the inverse of minus 2? Add 2. Whatever you do to one side, do to the other. The reason I did that is so that those would cancel because 2 minus 2 is 0. So now you have y plus 0, or just y. And then I can do whatever I want to one side as long as I do the same thing to the other to balance it out. Well, 18 plus 2 is 20. There you go. Now, a smart thing would be to check it. Your original equation is this. Y minus 2 equals 18. Replace y with what you think it is. So I replaced y with 20. 20 minus 2 is 18. Bring down your equals, bring down your 18. That's a true statement, so then yes, 20 is indeed the correct answer. Okay. To get p by itself, what's the inverse of adding 4? Subtracting 4. Do the same thing to the other side. Those cancel because 4 minus 4 is 0. So now you have p plus 0, or just p. And then 12 minus 4 is 8. Okay, put p equals 8 in your answer column. And then just to make sure that you got it right, might as well check. So replace your variable with what you think it is. You think p is an 8. And then 8 plus 4 is 12. Bring down your equals, bring down your 12. That's a true statement, so yes, 8 was the right answer. Okay. This time, what's happening with the 6 and the n? They're being multiplied because when you have no sign between a number and a variable, when they're touching, that means they're being multiplied. So the inverse of multiplying is to divide. The reason you do that is because anything divided by itself is 1, right? 6 divided by 6 is 1. So now you have 1 times n, or just n. So divide the other side by 6. 24 divided by 6 is 4. Okay, and then to be safe, let's check. So 6 times something is 24. We think that something is a 4. 6 times 4 is 24. Bring down your equals. Bring down your 24. True statement, so yes, 4 was indeed the correct answer. Okay, last one of these. To get x by itself, what's happening here? Well, it's being divided by 3. So the inverse of dividing by 3 is to multiply by 3. Whatever you do to one side, do to the other. Now those cross cancel, right? Think of it like, let's say you had, I don't know, this is a 4 and this is like a 10. Okay, if you were multiplying right here, these fractions, wouldn't these two 3's cross cancel and each become 1, right? And then you could say, oh, 2 could go into both of those. And that would be a 2 and a 5. So you're using that type of logic for this problem. Okay, these 3's are across from each other, so they become 1 and 1. Now you just have 1 times x, which is x. Since we multiplied by 3 to get that 3 to cancel out, multiply this side by 3. And 15 times 3 is 45. Okay, to double check, you have x over 3 equals 15. Replace the x with the 45. When you have a fraction like this, it's saying top divided by the bottom. So 45 divided by 3 is 15 equals 15. True statement. 15 does equal 15. So yes, that's the right answer. And when I say true statement, that means it didn't end with like 15 equals 10. That's not true. Okay, it needs to be the same number on both sides that they simplify to. That's a true statement. And if you end with a true statement, then you know that that was the right number. Okay, now when you see the word solve, that's what we do. We isolate the variable by itself. But if you see the word evaluate, what we're going to do is we're going to replace that variable with what they tell me it is. They say V is 4, so replace the V with the 4. Then W, they tell me, is 16. Okay, so 5 times 4 is 20 plus 16. Well, 20 plus 16 is 36. Okay, so I evaluated. Notice how I didn't do any inverse operations here because there was no equal sign. There's no like other side of the equation for this, right? So I can only do whatever I want as long as I do the same thing to both sides. Okay. For this one, it's another evaluate. So I'm going to substitute in what they tell me. They say X is 2 and Y is 7. Otherwise, it looks the same. Okay, within the parentheses, I can simplify. 2 times 7 is 9. And 3 times 9 is 27. There you go. Okay, on the other side, it says Javier is saving for a new pair of shoes that cost $59.99. So far, he has saved $22.50. How much more does he need to save? What do you think I would do? Well, he needs about $60. He's already saved this much. So if you, yes, subtract them. Okay, so 59 minus 99, or sorry, 59.99 minus 22.50. That'll tell me how much more he needs to save. So 9 minus 0 is 9. 9 minus 5 is 4. Bring down your decimal. 9 minus 2 is 7. 5 minus 2 is 3. So he needs to save $37.49 more. Okay, the next one says Mai's dog was 6 pounds when she brought him home. Her dog gained 28. How much does her dog weigh now? Okay, so what do you think? How would I figure this out? Well, it started at 6, and then you gained 28 more. So add 28 to that, and that'll tell you how much it is now. So 14 plus 1 is 34. So now it is 34 pounds. Okay, again, remember, you're always free to pause the video and try it yourself first, and then unpause it and join us to check yourself. Okay, the income from the soccer club's bake sale was $355. Expenses for the sale totaled $45. Find the total profit or loss from the bake sale. Is expenses adding or subtracting? Expenses cost you money, so I'm going to have to subtract that amount from my profit. So basically, it's like you don't just have the materials, right? You have to go buy the flour and the chocolate chips and things like that. If you're making a lot of cookies, you need to buy a lot of stuff. So you made $355, but you have to take account all the expenses that were $45. If you're like, that's not that much, we'll think of eggs, flour, sugar, all the different things that go into it to make things. So yeah, it was expensive. So you need to deduct that from how much you made, and then that'll tell you how much profit you actually made. Okay, 5 minus 5 is 0. 5 minus 4 is 1. Bring down your 3. So luckily, your profit was $310, and it wasn't a loss. What it means by if it's a profit or loss is that sometimes you can make this, but what if your expenses were $400? That would mean that you actually got a loss. You would subtract the difference between 400 and 355, and then it would be a negative amount, so it would be a loss. But luckily, our expenses were less than how much we brought in, so we're good to go. It was a profit of $310. Okay, the next one says the income from the first day of Jane's cookie business was $80. The expenses were $150. Find the total profit or loss for the business so far. Okay, why don't you guys try this one? Okay, you paused it and then you unpaused it. You're back with us. So, okay, you have 150 and 80. Always put the bigger number on top. So I'm going to subtract these to find the difference. 0 and then 15 minus 8 is 7. So you have $70. But unfortunately, the expenses were this, and then this was the positive amount. So you had more negatives than positives. So that means that this was actually a $70 loss. You spent too much money that, yeah, you brought in $80, but you spent more than that. So it was a $70 loss. Okay, for the next page. It says the highest temperature recorded in the town of Eastside this summer was 96. Last winter, the lowest temperature recorded was negative 13. Find the difference between the extremes. All right, so we have the difference between 96 and negative 13. So basically, this is saying the opposite of a negative, which is a positive. So you have two negatives next to each other with no numbers in them, like they're just two negative signs touching. You change them to positives because it's the opposite of a negative is a positive. So now I'm going to actually end up adding those two numbers. And you get 9, 9 and 1 make 10. So the difference between those was 109 degrees. And if you're like, how in the world did that work? Let's use smaller numbers. Let's say, okay, here's 0. And the highest we'll just say is 10, okay? And the lowest we'll say was negative 3. So what's the difference between those? Well, in order to get from negative 3 to 0, you would go 1, 2, 3. And then to get from 0 to 10, that's 10 away, right? So what's the distance from here to here? It's 3 plus 10, which is 13. So you end up adding those two numbers when you're finding the difference between them, and one's on the negative side and one's on the positive side. Okay, that's like a little visual to show you why we added those, but with smaller numbers. Because no offense, I didn't want to do a number line of 96 and 13. Okay. This one says the highest temperature recorded in the town this winter was 20 degrees Fahrenheit. Last winter, the lowest was negative 30. Find the difference between them. Again, we have two negatives next to each other, so change them to positives. 20 plus 30 is 50. Because again, remember, you had a negative 30 over here and a positive 20 over here. So you need to first go from 30 to 0, which is 30. And from 0 to 20, which is 20, 20 plus 30 is 50. Okay, the GCF. Remember how to find the GCF? It's the greatest common factor, the greatest number that can go into both of these. And to help us do that little upside down cake, okay, or the ladder, what can go into both 12 and 20? 2 can. 2 times what is 12? 6. And 2 times what is 20? 10. Can anything go into 6 and 10? Or are we done? Yeah, 2 can go into both of those. 2 times what is 6? 3. 2 times what is 10? 5. Can anything go into 3 and 5? No. So now we're done. So multiply the numbers along the side. 2 times 2 is 4. Now, some of you guys were like, oh my gosh, I missed it because I did a different ladder. And you saw this and immediately you saw 4 could go in. Well, 4 times what is 12? 3. 4 times what is 20? 5. Can anything go into 3 and 5? No. So then there you go. There was your GCF along the side. You just had a shorter ladder than we did if you saw a bigger number at the get-go. But we still got the same answer that 4 was your GCF. Okay, let's try another one. The GCF of 18 and 30. What can go into both? 6 can. 6 times what is 18? 3. 6 times what is 30? 5. Can anything go into those? No. So 6 is my GCF. And again, if you saw something smaller, like 3, well, 3 times what is 18? 6. 3 times what is 30? 10. What can go into 6 and 10? 2. 2 times what is 6? 3. 2 times what is 10? 5. Can you keep going? No. So multiply the numbers along the side. 3 times 2 is still 6. So no matter what, we got a GCF of 6. And even if you would have started with 2 on the outside, you'll see you still would have gotten a GCF of 6. Now LCM is almost the same steps. Okay, so start it off the same. Okay, what can go into 15 and 20? 5 can. 5 times what is 15? 3. 5 times what is 20? 4. Can anything go into 3 and 4? No. So then instead of just circling this, that would be the GCF. 5 is the greatest number that can go into both, but LCM is the smallest number that they can both multiply to become. So multiple is a number they can multiply to become. Factor is a number that can divide evenly into them both. So 6 is the greatest number that can go into both. We want to figure out the smallest number that both 15 and 20 can multiply to become. So instead of just circling this, I'm going to do an L for LCM along the outside. And so you have 5 times 3 times 4. Well, 4 times 3 is 12. 12 times 5 is 60. So 60 is the smallest number that both 15 and 20 can multiply to become. All right, use the distributive property to find the equivalent expression. So multiply 4 times 2x, bring down your plus sign, and then distribute that 4 to the 6 as well. Well, 4 times 2x is 8x, plus 4 times 6 is 24. I can't combine the x and the 24 because they're not like terms, so I just keep it as 8x plus 24. All right, and I'm going to stop at 20 because that's a good stopping point. So let's try these last ones up at the top. Write 3 equivalent fractions to 27 over 30. Okay. So in order to create an equivalent fraction, as long as I multiply or divide the same number to both the top and the bottom, they'll be equivalent. So let's try dividing. What can go into both of these? 3 can. 27 divided by 3 is 9, and 30 divided by 3 is 10. So 9/10 is equivalent to 27/30. Okay, could you have divided by anything else? Can you think of anything? Can anything other than 3 go into both of those? Okay, well then, if you can't think of anything dividing, then why don't you try multiplying? Let's try multiplying them both by 2. 27 times 2, you get 54. And 30 times 2 is 60. So 54 over 60 is equivalent to 27 over 30 because I did the same thing to the top and the bottom. And then instead of doing times 3, one suggestion that's really easy is to multiply by 10 because all you do is you just tack a 0 on at the end. So you have 27, tack on a 0, 270. 30 and tack on a 0. So 30 times 10 is 300. So 270 over 300 is equivalent to 27 over 30 if you just reduce it by 10. So those 3 would be equivalent to 27 over 30. Again, those aren't the only options. As long as you did the same thing to both the top and the bottom and didn't make a mistake, then it'll be equivalent. Okay, this one says write the fraction 13 over 25 as a decimal. There's one way that always works, okay? You can take the top and divide it by the bottom. So if you have a calculator, that's really nice. Just do 13 divided by 25. Well, 25 can't go into 13, so you add a decimal and a 0. Now, how many times does 25 go into 30? Well, think of quarters in $1.25. How many quarters does it take to make $1.25? 4 to make $1 plus 1 more to make 25 cents, so 5. So that's 125. Subtract 130 minus 125 is 5. Bring down another 0. 25 goes into 50 twice. So you would get that 13 over 25 is equivalent to 0.52. This way always works, taking the top divided by the bottom. But a nice way that sometimes works is if you can get this denominator to become 10 or 100 or 1,000, because then we could easily change any fraction with 10, 100, or 1,000 at the bottom to a decimal, right? Well, I can't make 25 become 10, but can I make 25 become 100? Yeah, if you just multiply by 4. So then do the same thing on top. Do 13 times 4. Well, 13 times 4 is 52. What's 52 hundredths as a decimal? It's 0.52. There you go. So this way sometimes works. If you can get the denominator to become 10 or 100, then you can change that to a decimal. Or this way always works. Take the top, divide it by the bottom, and then you'll get what it is as a decimal. All right, and we're going to take a break from there.